Alright, so do you remember our little cheat sheet we were working on here? Oh, we talked about system number 1, absolute coordinates. We talked about how it worked, the input, and we talked about some examples of valid input for absolute coordinates. Well, let's talk about system 2. And what is system 2? Well, system 2 is relative coordinates. How does it work? Well, you write down something that makes sense to you. For me, I think it lets you forget about the number line and allows you to specify the change, or the delta, from one point to the next. But again, that's my definition. You should have something that makes sense to you. If you were going to explain how relative coordinates worked to a 10-year-old, what would you explain? What would you tell them? Input, right? After our first point, we have to have the at sign, and we have at delta x, comma, delta y. So the at sign means forget about the origin, forget about the number line, just go from my last point. And then what is the change in x and what is the change in y, with a comma in between. So ask yourself, hey, is this valid input for relative coordinates? At 5, 0, is that valid? You bet. How about at 0.25, 0.125? Yep, that would be go 0.25 to the right and go up 0.125. And then how about this? At -3, 2. Do negative numbers work in relative? Well, yes, of course they do. We've seen how they work. Negative numbers let you travel to the left or travel down, depending on which axis you're specifying. Okay, so make sure you've got your cheat sheet here all up to date with our two systems, because now we talk about our third coordinate system. And it's called polar coordinates. So, much like relative coordinates, polar coordinates allow you to be freed from the origin and not have to worry about the number line. Instead of typing in an absolute location, instead of typing in change, you're typing in distance, how far you want the line to go, and you're also giving it direction. What angle do you want the line to travel at? Now, the compass in AutoCAD is a little wacky. 0 degrees is to the right, and angles are measured counterclockwise. So what does that mean? Let's take a quick look. So on page 10-12, we see the AutoCAD polar coordinate compass. Here is 0. So if you're here and you want to go to the right, when it asks you for the angle, you say 0. If you're here and you want to go up, well, then the angle is 90. If you're here and want to travel left, the angle is 180. And if you're here and want to travel down, the angle is 270. Okay, so those are your basic 90-degree quadrants as we work our way around the compass. After we specify our first point, our absolute point, we're going to tell AutoCAD at, which means forget about the grid and the number line and the origin, just go from wherever I clicked. Then we're going to type in a number. The number will be how long do you want the line to be. Then you're going to type in the less than sign. And the less than sign is on your keyboard if you hold down the shift and you hit the key with the comma, right? That's the less than sign. And then we type in the angle that we want to bear to. All right, so let's take a look at an example here. We've got some polar coordinates. I'm going to click here. I'm going to start here. And to get from here to here, my distance is 4, so at 4, and my angle is 0, straight to the right. Bam. Now to get from here to here, I said at 4.48, that's the distance I'm traveling, and my angle is 63 degrees. Boom. Right, and we just do the same as we go around from point to point. What is the distance, and then what is the angle? So now if we took a look at our course pack, at our examples that we're working with on page 1014, where we have a little practice using the same exact figures we've been using, except now we're going to try to do this with polar coordinate entry.